So I'm starting a new series where I'm reviewing code. I'm a C++ engineer. I do this a lot. I do a lot of reviews in general, code reviews. I do quite a bit of code review on open source projects as well. So yeah, let's get into it. For the first episode, I'm obviously going to review my own code, just so that it's a little bit more fair. And also because there's really no point in me reviewing other people's code who haven't agreed to it yet, unless, nobody says, oh, please review my code, then I'm just going to pick random fucking projects. Okay, so we're going to look at my repo here. This is the CHIP-8, a CHIP-8 emulator, basically. I'm going to look at the main file first. I haven't looked at it. I just made sure that it compiles, which is the first thing I do usually, and it does compile. We have, just for transparency here, we have three files, the CHIP-8cc file, the CHIP-8hh file, the main.cpp. This, okay, first part of the code review, obviously, this is a goofy ass naming scheme. Don't do that. Use .cpp and .hpp maybe, or anything that's kind of, normal. I mean, .cc is used a lot, but it's not used that much. It's like depending where you go, some projects will use exclusively this, but if you're making your own project, there's no point to doing it. So just use a normal one. Okay, also we can see that the file that's the biggest here is the chip8.cc with 19 kilobytes. So that's kind of what we're going to look at last. And we're going to start with main CPP. There it is. Okay, so what have we got? We're using SFML. So this is a 2D rendering library for C++, pretty cool. Let's see what else we have. We have a, looks like a singleton pattern for CHIP-8. So singleton just means it's basically a glorified global variable. Then we've got a beep here. And from what I know about what I remember about this architecture, to be honest, I wrote this code 5 years ago, so don't remember much. What I remember about the CHIP-8 architecture is that it basically has a screen that you can render to. It has, let me explain really quick. So CHIP-8 is an architecture that is made up, like it's a computer architecture that is completely made up for educational purposes. So it's quite easy to understand, quite easy to write compilers, assemblers, and of course, emulators for. So it has graphical output and it has beeps, as far as I remember, and it has instruction set. This emulator only supports the basic instruction set. There's like Super CHIP-48 or whatever it's called, not implemented here, and I don't think I care. So with that out of the way, I think we all know what roughly we can expect here. So it looks to be wanting to load Space Invaders. I don't have that, but we're not going to run this program. Doesn't really matter. It's not about that. It's about trying to figure out if this is good code, how we can maybe improve this. And we're just going to get into it now, finally. God damn it. Okay, so let's see what we have here. We have beep. Seems to just use SFML to play beep. Simple. This arguably should be static, just should be, you'll see a little thing here to the left if I modify it. So that's how you know what I've done basically. And, a doc comment wouldn't hurt about like, plays a beep, used by XYZ to do A, B, C, explanatory, don't repeat what it says, say why it exists, right? And maybe even look if it's used. Yeah, it's used. Okay, so that's awesome. Okay, this is pretty good. I would still do like that today if I did it. CHIP-8.initialize. Okay, we'll have to look at the code, but usually a pattern of calling an initializer is not great. The reason for that is just because there is RAII, which is resource acquisition is initialization. And the way it works is basically using only constructors and destructors to manage what's initialized and what's deinitialized. So here in this case, we don't want to actually call .initialize. Instead, maybe we want to not have this be global and instead just do this maybe with a little curly braces to make sure that it actually, looks initialized just for consistency with the rest of the program, and then put the initialization code in there. But we'll see how that goes once we look at the code. Then we obviously set a beep function. Looks like that's important. I'm gonna guess that there's a beep instruction of some kind. Let me check really quick. Yeah, sound timer. Once the sound timer reaches 0, it plays a beep. Okay, fair enough. We'll get into that. Okay, then we load a program from a string. Again, maybe arguably this should be from file, and then there should be a load program that just takes a string or a vector of bytes of some kind, because you might not, whoever uses this might not just have it in a file, so they might have to go and put it into a file just for this thing to load it, which is kind of stupid. So maybe they already have it in memory, maybe someone's building an assembler and stuff like that, but let's ignore that here and just pretend that this is fine. Making SF window, making SF window is kind of straightforward. We clear, this is not necessary, but sure. Yeah, no, I'm not gonna format the code actually right now. Looks like this limited to, let's look at what this function does. Can we do that? Oh, maybe we need to, we do have to build this really quick so that that we know what's going on actually. So this is just a little thing I do for my Vim config. You can basically ignore this. And now we should be able to go in here. Maybe not, doesn't matter. Okay, so set frame rate limit, I'm pretty sure it takes a frame rate. So this comment is probably wrong, but I'm not sure. So let's leave it like that. What else have we got? A vertex array. Okay, so it's like an OpenGL vertex array object, if you know about that. You're basically, you're basically making a vertex array as a collection of quads, like rectangles on the screen, so that you don't have to subdivide them into triangles or anything. It's just super simple, and we're making 64 times 32 times 4, which looks to be all pixels basically. So we have fake pixels that are just quads. This is fine. There are not that many of them. What have we got? Got a while loop. We'll get into that. Oh, okay. All right. There's some handling here for keys. Fair enough. Could abstract this away somehow, but I guess not. This seems wrong, but I'm not sure about it of now. But like having both of these might not be necessary. But it depends, I guess, how the user also. Okay, so these have been pushed to Git, which is shit. They need to be deleted. Obviously, they're commented out code. There's no reason to keep commented out code around ever if you're using Git or any sort of source control, because there's no point, right? If you need that to get that back, just look in the Git history. That's the whole point of it. Don't comment out code, leave it around. Not good. Okay, so let's look at the header now of CHIP-8. So assuming this defines the CHIP-8 class. Now this is fine. And what else have we got? We got the CHIP-8 class here, and then immediately public. Okay, so reasonably this should be a struct, right? Because there's no point in doing class and then immediately saying public. It might help some people, doesn't really help me, to be honest. Then we have presumably the virtual machine's state here. Yeah, looks like it. And the beep function, which this is not great, honestly. This should be a standard function. This should be a standard function of, what was it, like just void, I guess. Like that. That's what that should be. The reason is just because you can pass it around easier. You can use lambda. There's a bunch of stuff that is positive about this. The basic idea is just this is C++, the other one is C. We don't write C when we say we're writing C++. That's not going to happen unless there's like a super good reason. And if there's a super good reason, it better be like, here, this is the reason for this. Blah, right? If it's not there, there's no reason, so skip it. Okay, looks pretty straightforward. Let's look at the header, the source file. So that's 470 lines of code. What have we got? So the font set, assuming that's given by the machine somehow. Here's the initialize function. Okay, so here's exactly what I was saying. There's no point to having an initialize function if it doesn't do anything incredibly dangerous that you can't do in a constructor for some reason, right? So with the initialize function, you're gonna say, okay, we're gonna not do this more than once, and you basically guaranteed that. But with the constructor, it's the same thing, especially if you mark the class as non-copy constructible, not movable. So again, no point. It should be the constructor. This should be just the constructor. That's literally it. And because, so the reason, obviously, I need to give a reason, right? So that it makes more sense. When you make a CHIP-8 object, right? And you don't call .initialize, but you call any other functions, then stuff isn't initialized. And you cannot have uninitialized stuff. It's not a good idea, right? And yeah, because it's undefined behavior to access it. That's basically it, right? So if you read from an undefined variable, like for example, standard CLX, right? This is undefined behavior right here. That's not allowed. Okay, so we can't be having this sort of let me undo that really quick. Okay, can't be having this sort of code where we initialize like that, because you can forget, because you can call it twice on the same object, which might cause all sorts of issues. You might have a reset function of some kind, and then just have the constructor call it, right? That's okay. Like that, that's fine. But don't just have an initialize function, call it. That's super dumb. Just not good design, right? Again, unless you have a really good reason to. If you do have a really good reason to, then you better write it somewhere. Otherwise, someone else going to go and fix it for you. Chesterton's fence says, don't change what you don't understand. But at the same, unless you can explain why it's there, don't change it. But in code, that doesn't apply all the time. Usually, if there's no comment, then there is no reason, so you can change it. But yeah. What have we got? Program counter, opcode. Okay, I'm guessing they all have to be reset to these values. Clearing these with memset. What are these? Okay, we don't have the... Let's see. This is the header here. Okay, these could be standard array. That would actually be better if these were standard arrays. I didn't look at these yet, so these should be standard array of char, or if it's unsigned char, then really what you want in this case for the GFX, for example, is you want a standard array of uint8t, because you do want to guarantee that it's 1 byte. You do want it to be unsigned. So there's no reason to use unsigned chars. There's way more to read. And then you want, this is 64 by 32, which you might put in a variable of some kind or not. But this is gonna make your code a lot better, because it's safer. You can carry around the size of it. And when you do, when you change this type for some reason, maybe you change it into a 2 by width, then suddenly all your code breaks, because you did size of GFX, and that gives you the amount of elements, not the actual size. So maybe that's not what you want. Maybe that is what you want. But either way, this is not very explicit about what you actually want. So don't use it at C. Don't use it. You're not writing C. You're writing C++. Okay, what else have we got? We got stack, registers, and memory. Probably the same exact thing. Here you see the size of that I was talking about. And really, if this was an array, you could just use, I think, just initialize them properly, and you wouldn't have this problem having to memset them. Fair enough. Let's move on. Load program, very straightforward. I mean, fopen is kind of ass. Again, this shouldn't need to fopen. This should just take the bytecode of the program, because you're doing multiple things here. You're not checking if fopen failed, which, by the way, is why the program crashes if I run it without a file present. Read without checking. This should be this is trivial to do. It's literally this. And then if red's blah, 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 right? Then you can do like p error if you want. It doesn't matter, but just do any kind of error handling. Like at least pretend you care about error handling. Or just pass in the code and don't pass in a file name and then read it. It's just kind of weird. This is an unnecessary piece of code. You want to use standard copy. Why? Well, because you can't have an off by one error. Well, you can, but it's really difficult to have an off by one error in a standard copy or some sort of other algorithm, and they're kind of easier to read than this. Though in this case, I would excuse this if this was at least a standard array and you were using .add, but you're not. So again, penalty for that, if you will. These are all things that in an actual legitimate code review, I would either only comment about, or most of these I wouldn't probably say in a real code review because depending how much I care, right? But in this case, I probably, if I want this code to be good, I would actually probably require all of these things to be changed before it's merged. Like, for example, if it's one of the open source project that I maintain, you would definitely not get this code through a code review. But it's easy to fix. I would just basically say fix this, fix that, blah blah blah. You would fix it, and it would be fine. Now emulate cycle seems to be probably called in a loop somewhere. Oh god, that's a long function. Okay. Okay, emulate cycle should be called. It's probably called in main, to be honest. Let's see. Oh, all the drawing code is there too. So yeah, emulate cycle, and then we draw what the graphics memory shows. That's fair enough, I guess. And we've seen this. This is not particularly interesting. So let's not look at that any further. I'm just looking at sort of bigger design decisions, not the nitty gritty of did you write the if statement in the right order or some shit. Okay, fair enough. So this is great. The amount of comments here is really nice because this is very hard to read otherwise. Though stuff like this should probably be abstracted in some way if it's possible. But then again, this is a virtual machine of some kind, like an interpreter, a bytecode interpreter. And so there's no real reason to abstract too much because you do want this. This is the hot loop. This is literally the hot loop of your VM. So you probably want this to run fast. Though seeing how we're rendering with SFML, we might not actually give a fuck. So if we don't give a fuck about performance, let's actually write this code nicer. And these printfs obviously should probably be the FMT library or some other formatting because it's kind of fast, but it's fine, I guess. I guess this is fine. But yeah, comments would be nice. There are some comments here, but like explaining what this is would be nice. Like I know what this does, right? We're extracting this byte from the opcode. But yeah, I don't know. Seems a little weird to like not show what is this actually. I mean, this is a skip instruction, I guess, but yeah, I'm seeing this a lot here, so maybe we could comment a little bit more about what that is. The printfs are also sort of a comment, I guess, because you can kind of reverse engineer. Okay, this is, so let's see, maybe this. Yeah, okay, so this is this, I guess. Yeah. These nested switches should really be functions. They can be inline functions. They're gonna, be optimized in. It doesn't matter, but make more functions. Other than that, this looks pretty good. Ooh. Okay, yeah, no. This needs abstraction or comments. This is not like or unit tests even. Like, what is this? What is like x plus bits plus y plus row times 64? Like this is basically mapping a 2D space into a one-dimensional space by basically taking, okay, if I have this many, like this is the column I want, and this is, oh no, this is the row I want, and this is the column I want. So I take this many. So if I want this many columns, then I want to skip 64 rows, or like 64 times this, to basically get to the point in the array that if you were to draw in 2D would be that row. It's like, this is super common math. Like you see this in every single renderer that uses a one-dimensional array to store the actual data, and then a two-dimensional sort of access pattern. But the problem with this is just that it's not very easy to understand. And so, maybe fix that. What I do have to say is nice is that these for loops are in the right order. So the row first and then the what's called the bits here, because the bits will change sort of granularly, where the rows will jump by 64. So it's good to do this in the inner loop to make sure the cache is being utilized properly. Guessing that's fine. Maybe this access here could be simplified because we're doing it twice. Maybe we could just comment like row x plus bits, column y plus row at least, and then have it be maybe a reference. Maybe we call pixel and we put this here, and then pixel, and then pixel goes here too. Because of reference, we can do that. And this is a lot easier to read for me at least, and you only have to understand this once. You don't run the risk of having to like go and change this and then forgetting to change this, or whatever it is, like this to a 3, and then you don't change that to the 3. Like it's just better code like that. Okay, yeah, this needs a bit more explanation, and maybe there's something built in to do BCD, but maybe not. Not sure, I haven't looked this up. Okay, and then we have type logic at the end, and then we have re-arcade. We go to that. We do go to that. Okay, this is probably an acceptable case of goto, to be honest, because it is control flow, and it's not like we're doing anything in here other than logic. Like we're not allocating in here, we're not deallocating anywhere, this is basically, there's no allocations in the entire function here that we have to control. Everything is managed by constructors and destructors, again, RAII, so we don't have to worry about it. And we are approaching 22 minutes or 23 minutes, which is absolutely messed up. So I should probably shut up and say my final words about this. Yeah, so I would say in general, considering I wrote this 5 years ago and I was pretty much a beginner at C++, pretty good. There's quite a few things that I didn't look at properly, like error handling, but I don't think there is a lot of that in general. Let's look at the main.cpp really quick. Yeah, there's not a lot of error handling, but that's probably fine. I know that. Oh no. Oh, I didn't even see that. Oh, that's not good. Okay, so we're leaking memory. We're leaking the window here. What this should be, because there's no reason for it to be a pointer. It should be this. It should just be on the stack or automatically allocated, however you want to say it, because there's no point for it to be dynamically allocated. This is a pattern I see a lot in graphics programming, that people have no idea what the fuck they're doing, and so they start using new everywhere they can, and pointers and stuff like that. And the basic rule of C++ programming is pointers just don't. And if you do, then you do shared pointers or unique pointers. You don't do raw pointers. And if you do raw pointers, you better have unit tests. And if you do raw pointers without unit tests and you don't have fuzzing and everything, you better run your stuff with a lot of sanitizers, and you better be careful, because that stuff is not funny. It usually doesn't do what you think it does. And there's usually actually no point to using them. You're probably just wrong if you use them. So don't. That's the basic understanding here. Use references where you can. Use value semantics where you can. And yeah, hope you enjoyed. That's my code review of this ancient code base of mine 5 years ago. And yeah, hope you learned something.